in Python with scikit-learn. This will not take too much time, so we are going to run it, yeah, quickly, and then yeah,
Yeah.
good. So, Sebastian, thank you, and time is yours. Yeah.
All right. Um, hmm, uh, please, are you able to see my screen?
And yes, we can see your screen. Yeah.
Right, fantastic. Okay. So this morning we're going to do decision trees with Python, in Python with Sci-kit learn. So in machine learning, we have the supervised learning, which is one aspect of machine learning. And decision tree is one of the supervised machine learning algorithms. And one of the unique things about decision tree is that you can use it for classification problems and regression tasks as well. Okay. Now, for how decision tree works, for every feature, the decision tree algorithm forms a node where the most important feature is placed at the root of the node. Right. So let me give an example. Let's say you have a car and you want to give a car to someone. Someone wants to borrow your car for something or to use your car for some rounds. Okay. Now there are a number of things you're going to consider before you either reject their request or you grant their request, right? And one of them definitely is going to be whether you have a relationship with the person. Okay, whether the person is a friend, as a stranger, or is just an acquaintance. Okay. Now, when you have that, then maybe the next line of action could be whether this is the first time they are requesting for it, or this is the second or more times they've been requesting for it. Then maybe another point for consideration could be if it's more than the first time, or if they requested for it more than once, then you want to know whether they returned it in good shape. Okay. If they return it in good shape, then you may want to give it back to them again. If not, you may want to reject it. Okay. Now, when you look at these decision points, the most important among the three that I've mentioned is the relationship, right? That is the first thing that you have to consider. It comes before whether the person is requesting it for the first time or whether the person returned it in good shape. Okay. And so, what in decision tree, the most important feature is placed at the root of the node. So in this case, whether you have a relationship with the person or not, becomes the root node, becomes the first thing that you consider, right? And then you work your way down, right, by following the node that meets your condition, or by following the decision points that meet a particular condition. Okay. And then when you get to the end, which in this case will be the leaf node, right? When you get to the end, then you'll be able to know the predicted outcome. Okay, so I hope that is clear. Now, the advantages of decision tree, as like I mentioned earlier, it can be used to predict both categorical and continuous variables. Less effort is required in training them, and they're very fast compared to other classification algorithms. So we're just going to do a quick demonstration. We're going to predict whether a banknote is fake or authentic based on the following attributes. Now, in machine learning, the typical steps in machine learning include, so you need to import your libraries and data sets, conduct some data analysis, you split the data into training and test sets, you train the algorithm, you make predictions, and you evaluate the performance of algorithms, right? It has left out some parts. things like feature engineering and feature selection and all those things. But then on a very high level, this is the common steps that you go through. Suppose that suppose that you have one of the cleanest data sets, everything is ready and all that. This is sort of like on a high level, this is the steps that you go through, okay? So we're importing our libraries, we do data analysis, this is a very minimal, we're just checking the shape and then the head, that's all. So in preparing and splitting the data set, so this is with the assumption that everything is fine, no data cleaning required, all the features that we see here are perfect, and we don't need to do any feature engineering or feature selection. So in that case, what we do is all the features are given to the X in exception of the dependent variable, in this case, which is class, okay? So the Y becomes the dependent variable, which is class, and then the rest of the features are the X, okay? And then like we learned the other time when we went through the sklearn Python library, it comes with sub modules, right? And among them is the model selection. Okay, and then in the model selection, we have the train test split, right? The function that helps us to randomly split our data set into training and tests, right? So we specify the size of the test, which is 0.2. In this case, what we are trying to say is that we want 80% of our data sets should be our training data set, and 20% to be our test data set. Now we have in sklearn, we have the tree submodule, which has a decision tree classifier. Okay, which is the algorithm that we're going to use to train, our data sets, right? So we call it, and then we use the fit. So the fit is the fit is the function that we're going to use to train our data sets, right? So it takes in the X train and the Y train. Then after training, then we classify. After training, then we predict. So we predict on the X test. Okay. Now we also have the metric submodule in sklearn. And in the metrics submodule, we are calling the classification report and confusion metrics, right? And when we do that, this is what we have, right? So we have an accuracy of, so if you have a precision of 96% for the, so if it's 0, it means that it is authentic. If it's 1, it means it's fake. All right, so we have a precision score of 96% for authentic and then 100% for fake. Okay, and so on and so forth. Now, let me make some little comments on the confusion metrics. I don't know why they call it confusion metrics, but it's actually confusing though. So in confusion metrics, we have what we call the false positive, true negative, and false negative, right? What do they mean? Now, in this context, we are trying to predict whether a currency is fake or not. Okay. Now, if the currency is authentic, it is positive. If it is not authentic, it is negative. Okay. I hope we get that. If it's authentic, it's positive. If it's not authentic, it's negative. Now, what is the meaning of true positive? True positive simply means that the currency is authentic, and then the model told us that it is authentic. So in that case, it is true positive, right? The thing was authentic, and our model told us that it is authentic. So that one is true positive. Now, the false positive is that the thing was authentic, but the model told us that it is not authentic. That is false positive. The thing was authentic, but the model told us it is not authentic. That is false positive. Now, true negative is the thing or the currency is not authentic. The true negative is the currency is not authentic, but the model told us it is authentic. Okay. True negative. The currency is not authentic, but the model told us it is authentic. That is true negative. And then no, True negative is the model. True negative is that the currency is not authentic, right? It's not authentic, and the model told us that it is not authentic. So that is true negative, right? The currency is not authentic, and the model told us it is not authentic. So that is true negative. The false negative is the currency is not authentic. The model told us it is authentic. Okay, it's very confusing, but that's how it is. So now, like we said, we can use decision tree for both classification and for regression task. So now we're just going to demonstrate how it is done for regression task. Okay. So the only difference is that we use a decision tree regressor instead of a decision tree classifier. And then we have, yes. What's the question?
Okay, concerning the confusion matrix, I'm trying to relate it with the rejection of the non-hypotency and acceptance of the non-hypotency. And I understand that when you reject the non-hypotency, when you ought not to reject it, it is type 1 error, and it is, what they call it, is false positive. But I don't get when you that type 2 error, how do you relate type 2 error, that is the false negative, with confusion matrix? Because this morning I've been trying to relate it together, but I've not been able to get it. I only got the one error, which will give you false positive, which is correct. But when you make the non-hypothesis false, when you accept the non-hypothesis, when you ought to reject it, which is type 2 error, I'm trying to relate it to the confusion matrix. I don't know if there's a way you can just give clear my confusion.
If you say you are trying to relate it to the confusion matrix, what exactly do you mean? Hello?
Yes, hello.
Yeah, so I asked him a question. If he's trying to relate it to the confusion matrix, what exactly does he mean?
Okay, basically, if with the confusion matrix now, when you predict something that is false, whereas it is true, then that will be false negative.
Come
And
again, come again.
in hypothesis, I think when the value is true, but the model predicts it to be false, that is false negative, if I'm right.
So when the value is true, right? And then
Yeah,
and then the model said it is
model
not
predicts
true,
that false.
that is false positive.
Yes, so I try to. I'm providing. I know this terminology are very confusing, so I'm
Yeah.
providing a link actually, and this should be helpful in a correct definition. I also put a small definition in the chat in post, which will help them. And here now I'm just sharing the link, and then we get from there any definition about the terminology. Yeah,
Okay, thank you.
Okay.
yeah,
Thank you very much, Jean.
yeah.
All right. Please, any question? Please, if you have any question, please feel free to stop me and then ask the question. Okay.
Yeah.
All right. So, uh, decision tree for regression, we use the decision tree regressor, and then the evaluation metrics are also different. Okay, so we'll get to that. So we're trying to predict gas consumptions in millions of dollars in 48 US states based on the following attributes. Okay,
Okay.
so we load our data sets, we do the describe. Now let's go straight to this side. So what we are trying to do is we are giving all the columns in exception of the petrol uh, consumption to X, and then giving the petrol consumption to Y. And then we do our splitting. In this case, we're giving 20% of our data sets to as our test size, as our test, data set, and then 80% as our training data set. So we call the decision tree regressor and then train the data set on that algorithm. So at this point, we predict. And what we're trying to do here is compare the actual values with the predicted values. Okay. Now, when you go through each of the values, you realize that you wouldn't find any of them that is the same. Okay, there are some differences. Okay, so you want to evaluate the performance of our algorithm. And we realize that the mean absolute error is 52.9. So in this case, that is 52.9 million gallons. And then the mean square error is 4681.7, root mean squared error 68. So now what do these numbers mean? The mean absolute error is just the measure of error between paired attributes expressing the same phenomenon, right? So it's just trying to say the error between the paired attributes. So in this case, actual and predicted, the error between them, okay? So that is that 52.9%, 52.9 million gallons. And then the mean squared error measures the average squared differences between an observed and predicted value. So the average squared differences, okay, between the actual and the predicted. And the root mean squared error is just the root of the mean squared error. Now, when you look at the mean absolute error, it's 52.9. When you compare it to the mean of the petrol consumption, which is 576 million, 0.77 million gallons, you realize that the 52.9 is less than 10% of this figure, right? It's less than 10% of this figure, which means that the algorithm did pretty good, right? So which means that and also remember that when we are predicting, we don't necessarily, especially when you're predicting continuous values, you don't necessarily need to get the exact figure, right? It is just like, let's say you want to get estimates of, maybe let's say you're moving into a new area and you need to make some estimates for interior decoration, right? Now, when you go out there to get your estimate is supposed to help you draw a budget, right? You don't need to get the exact values. It's just estimates. And then it gives you an idea of how much you have to budget for, to undertake that project. Okay, so in this case too, we don't need to have the actual values, but then at least the predicted values should be as close to the actual values as possible, right? In that way, it helps for proper planning, because if the predicted is too far away from the actual, then it becomes really difficult to rely on that predicted values for planning purposes. Okay, so having a mean absolute error 52.9, which is less than 10% of the mean, it tells us that our model did pretty good. Okay, so this tutorial is heavily picked from Stack Abuse, Decision Trees in Python with Sci-kit Learn. And then for further reading, you could also check out this link to understand more. Okay, so that is the end of the tutorial. This notebook is in today's folder of week 4. So you can go there to check it out. And the data sets are also there. The data set that I used for the tutorial is also there. So at this point, I'm happy to take any questions that you may have. Yes, Lasho. Lasho, do you have
Asking if we can use decision tree for a fake news detection system, and I say why not? Yeah, because the fake
Hello, Jean. Hello, Jean.
news a process which involves like continuous.
Can you repeat what you're saying again? We missed you for a while.
Yeah, can you hear me now?
Yes, yes.
Okay, so she was asking if we can use decision tree for fake news detection system, and I say yes,
Yeah.
because fake news detection system is just based on the fact that we have data generated from a binomial process, like not binomial binary process. Like if the news comes, we just have to classify it as yes, it's fake, or no, it's not fake. So we just said that decision tree is actually can be actually used to make both classification and regression. And even in classification, you can do binary classification or multinomial classification depending on your objective. So in this case of fake news detection system, you are just gonna use the decision tree to be to make binary classification. I think yes, you can do it.
Okay. Well, actually, is that clear? Okay. Any other question?
Okay, please. I wanted to ask about. You did not say anything about validation set. Like, how do we go about validating our data set? I don't
Oh
know.
yeah, you can use it. You can use it here. Yes. So it's like I think every time you are doing machine learning, like classification or regression, yes, you have to split your data into three kind of data. Yeah, like the training, the testing, and the validation. So it's not a problem if we don't need to apply this in the tutorial, but I think yes, it's you can do it. You can definitively do it in order to like check about what your model could actually, how your model will actually perform if you are not using the same data you use to train it. Yes, so you can do it. Yeah, you can split in validation and use the validation to compute the only things, the core things with validation and testing is that you are using them to compute like the metric to appreciate your model. Yeah, so the metric are a lot, so they are a loss function, and from the loss function you understand the metric things. And then yes, if you use the training set to compute the metric, it's like you are using the training data to also assess the model. So this is not, so you have to use the validation. Yeah, I agree with that. Yeah.
Okay, let me just try to explain what I understand with validation. I think there
Yeah.
will be training, like the way they explain it is like there will be 70, 10%, and 20%. So like they now said we should do it cross validation 5 times. So like for each times the validation set will be different for each of the validation that we're doing. Like we'll randomly just generate the train and test for each of them, and we'll remove out a different validation set for it. Is that how it is done? I don't understand.
Yeah, I think that's the core thing. Yeah, I think it's okay. I'm okay with your explanation on that. Yeah. So,
All right. Thank you very much, John. Any other question? Okay. So, John, I think there's no more questions. So,
yeah. So, Olasho, just to answer, like, I thought it was used only for prediction. Yes, for prediction, but prediction can be actually like classification or regression. Like, yes, you can use it to predict class, or you can use it to predict continuous variables. Yeah, so both are actually useful. Yeah. So I think, yeah, we are done. And Sebastian, you can stop recording. Then, if any other question, just slack about that, and